Hello, and welcome to Strategies and Discussion Model for Item Analysis, the first of 3 webcasts in the series, Mathematics, a look at the OGT. It's designed to support high school mathematics teachers who want to use Ohio graduation test results to improve student learning. My name is Peggy Costin, and I'm the Executive Director of the Ohio Resource Center for Mathematics, Science, and Reading. For those of you who are viewing live, you can participate in today's discussion by emailing your questions using the Submit a Question button. We'll answer as many of them as we can at the end of the live program. You'll also find support materials related to today's topic, including a webcast companion document, visualization, vocabulary, and implications, a handout of the OGT items to be discussed, and some other materials that will enhance the webcast experience. These items can be accessed at any point without disrupting the webcast. This webcast is predicated on the idea that the very best professional development is thoughtful conversation among and between faculty members as they consider the teaching and learning of mathematics. This webcast is not intended to provide silver bullets or even a prescriptive how-to method for preparing students for the OGT. Rather, it illustrates professional dialogue about student performance and provides some written materials that you may find helpful to stimulate dialogue in your own school or district using your own data. We will use state data to examine specific difficulties on some geometry items, suggest some interventions for those difficulties, and then acquaint or reacquaint you with some of the OGT resources available on the Ohio Department of Education's website. Today's panelists are Jim Wright. Jim is Assistant Director for Mathematics at the Ohio Department of Education. Jim was a high school mathematics teacher for 31 years before joining the department. Kay Wallace, who taught high school mathematics for 30 years and is now the mathematics supervisor for Pickerington City Schools. And finally, Carl Jones. Carl taught high school mathematics for 20 years and has been a mathematics curriculum consultant for the Darke County Educational Service Center for 10 years. Our panel is very knowledgeable about the OGT, but more importantly, they have all thought deeply about the kind of curriculum and instruction that will assure that all students learn rigorous, important mathematics, and as a byproduct, will easily succeed on the OGT. Jim, Kay, and Carl, welcome.
Thank you.
Thank you.
I believe that looking at how students answer specific questions can tell us a lot about how we should modify instruction. For example, today we will look at student responses around some basic geometry items. In 2004, there was an interesting item on the test. Carl, could you walk us through this item?
It says Daniel cut a corner off a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off?
Carl, this seems like a pretty straightforward, even easy item. Why do you think that fewer than 60%, 58% to be exact, of the students selected the correct answer? And what concepts and ideas would you emphasize for your students next year?
Peggy, let me take a second and talk about just the percentages on the data analysis, first of all. If the viewers notice that we had 3 and 4% answer A and B, which are not that logical of question or an answer anyway. So 7% were probably just landing on A and B by random guessing. Sometimes teachers forget that probably another 70% could have very well have landed on C and D just by random guessing. So the chances are that it's probably more likely that only 54 or 55% really knew the right answer of a triangular pyramid. The thing that draws them to C and D, I feel, is that the fact that they both have the word triangular in them. And so that's going to draw them to those two. But then what is discerning is that essentially about only 20% actually knew the difference between a prism and a pyramid. So this could be a vocabulary issue between the two words. And I guess what also makes this discerning is that the ability to identify between a prism and a pyramid is supposed to be a second and third grade indicator. And quite honestly, they may have very well have known that fact at that time, but maybe never reviewed this important information as it's gone along. So again, being able to look at this figure and visualize that part that's missing and knowing the definition difference between a prism and a pyramid, I think were some of the essential difficulties that students had with this problem.
Jim, do you have any additional thoughts about why students struggle with this particular seemingly obvious item, or are there any instructional implications?
Well, I'd agree with what Carl's had to say. I think also that the use of precise language, the language of prism and pyramid for some students is difficult. You know, sometimes we tend to not use that language every day in class. The idea of the visualization of three-dimensional objects in a two-dimensional drawing is very difficult for students, and that visualization I think also adds to it. So I think those 2 points, the language and the visualization, are two critical pieces.
Kay, would you like to add anything to this?
Well, I think that you would have to break this question apart into steps for students to really get to the bottom of why they chose the wrong answer. So I might begin with just pictures of what the corner that was sliced off might look like to see if they really can't visualize that corner or if they don't know the words to describe it. So you don't know which it is initially. And then I would also add that even at the high school level, you need to start with some 3D models and give students experiences with cross-sections, what the pieces look like after you've sliced them, what the cross-section looks like, leading into those higher grades, which would include conic sections and calculus and those kind of higher level thinking.